on form coefficients. Before I explain what are these form coefficients, today's lecture will be on form coefficients, and before I go in and explain what are these coefficients, then we have to make the hull form, that is the lines that has already been drawn, fair enough, or what is called fairing of lines. So, the lines plan that I have already explained consists of three projections. The first one is called the profile or the shear plan. Now, the profile consists of, as I have already said, that this is the baseline. Then the other lines, you have the deck lines, and you have your forward perpendicular, that is FP, and AP that has already been drawn, and the midship line has also been drawn, and in between FP and the perpendiculars, the length has been divided into equal number of stations. Say you can divide it into 10 or 20 stations as the geometry of the ship demands. Now, after that, we have demarcated the buttock lines. So, buttocks are again longitudinal projections taken at certain distance away from the center line. So, this may be one of the buttock lines. Now, we can see that the profile itself has a large number of lines, and none of them are having any distinct mathematical shape. So, this is the profile, and below the profile the half-breadth plan has been drawn. So, first one has to draw the center line, and since the ship is symmetrical about the center line, there is no need to draw the water lines on the other side. Simply you can draw it on one side, and that gives the half-breadth plan. So, this is just an outline of the actual drawing one has to make, and after one has made these drawings from what is called the table of offsets. I will explain what are these offsets. They are nothing but distances from the center line. This is the center line, and again this is the after perpendicular, and one draws the half-breadth plan. It is better to simply extend the station lines down below. So, this is your half-breadth plan. So, simply extend the station lines. And here one also can mark the buttocks. This can be say 1 meter buttock. This is 2 meter buttock. Say this is 3 meter. Like this, one marks the buttock lines. So, these are again shown on the half-breadth plan by horizontal lines. So this is 1 meter buttock, then this is 2 meter, 3 meter, like this you can mark. So this denotes 1 meter buttock actually denotes the longitudinal section of the ship that has been taken at a distance of 1 meter from the center line. Similarly, 2 meter buttock has been 2 meters from 3 meter, like this. And on the profile and the opposite, you can draw the diagonal or the breadths that lie diagonally from the body plan. So this is called a diagonal line. Now next is the body plan sections. So the body plan sections is simply you extend the baseline on the right hand side and draw the sections, that is the transverse, the outline of the hull form when there are vertical planes coming at these stations, say station 1, 2, 3, 4, 5 transverse planes, they intersect the hull. So those are called body plan stations, but before that one has to make the outline of the or the boundary of the body plan. So this is the depth of the ship and this is the maximum breadth. Of course, in the body plan section there is no question of the length coming into the picture. The length can only be shown on the profile and the half breadth plan, right. Now here you can draw the stations, the forward sections are drawn on the right hand side and the aft sections are to be drawn on the left hand side of the drawing. But station number 5 has to be repeated both on the right hand side as well as on the left hand side for continuity's sake. So this is station number 5. So here the aft sections are drawn. Right. Now in the lines plan it is better to make the grid. So this is the molded baseline or the datum line, which is our starting point. This is called the MBL or the molded baseline. Now the water lines are drawn vertically upwards from the molded sorry, from the molded baseline at specific distance or at equal distances, say at 1 meter interval you can draw all the water lines, and it is better to extend these water lines to the body plan itself. The body plan also it is better to mark the water lines. So water lines are nothing but horizontal planes intersecting the hull at specified distances from the molded baseline. So this is in short the lines drawing that has been obtained from a set of offsets. Just today I will be talking about the fairing, and on the body plan this is the body plan sections. Here again one can mark the buttock lines at distances from the center line. But again buttock lines have to be drawn both on the right hand side as well as on the left hand side, because the same distance you can see from the half breadth plan the buttock actually extends both forward and aft. So the same distance from the center line, say this is your 1 meter buttock, 2 meter, it has to be measured from the center line itself. So this is in short the lines plan that we have drawn, and in the lines drawing we can see that the ship has a large number of, this is of course depth, large number of curvature, and these curvatures are actually very important. The curvature of these lines, as you can see in the body plan sections and also in the profile by the buttocks, these are the buttock lines, and also these are the water lines. You can mark the water lines here. So this is your say 1 meter water line, then 2 meters, 3 meters, on top you have the deck line. Now you can also draw uh, the deck at side, or the deck at side will be one of these lines, and forecastle deck can be drawn here, and the poop deck can also be drawn at the stern. Now coming to the fairing of the lines, these lines, that is your buttock lines and also the water lines, the shape of these lines are very important. So a naval, when one makes the initial drawing, say a naval architect, what happens, the flow of water in your ship, you will find that the propeller is situated at the aft, and of course in the propulsion class you will be told that the efficiency of the propeller actually depends on the amount of water that is flowing into the propeller. Now, by any chance the propeller is not able to suck so much of water, and the propeller actually accelerates the water sternwards. That is how you develop the thrust. And this thrust is eventually through the thrust bearings, it is transferred to the hull of the ship. There are special bearings called thrust blocks which take the thrust. Of course, the intermediate you have the shaft bearings, and then it is transmitted to the hull and the ship moves forward. Now, from the naval architecture point of view, this flow of water to the propeller is of very uh, 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 large importance. So this flow is governed by the slope of these buttocks or slope of the water lines. This distinct slope of these lines, and these actually vary from ship to ship. So when my previous lecture, I told you that how this lines plan has been obtained from what is called the section area curve. So again, I am not explaining the section area curve in detail, but in any ship hydrodynamics book, you will find that the nature of the curve, from the nature of the curve, you will get the nature of the lines. So this is very important. This nature of the sectional area curve, and you will find if you look into any ship hydrodynamics book that this sectional area curve is different for different ship types. So in the sectional area curve, the ordinates are the sectional areas at the various stations. Stations are nothing but the positions along the length of the ship. The length that you have already marked, that is called the LBP, between the forward perpendicular and the after perpendicular. They are divided into the equal number of parts, and these positions are called stations. So similarly here also you have to measure the stations, and you get the sectional area, right? Now, in any hydrodynamics book, you will find that the slope of this sectional area curve, say at the forward end and also at the aft end, is defined. That means there is specific slope, like this. Then you have a parallel middle body and so on. Now, all this will be reflected in the nature of your lines. So, together with the sectional area curve, you have to find out what should be the best slope of the buttock lines and the water lines. Now, one thing should be kept in mind when the ship lines are drawn is all these lines, of course, in the diagram that I have drawn, the buttock, says the 1 meter buttock is looking very crooked, but in actual practice it shouldn't be like that. But all these lines should be very smooth. That means there should not be any undue inflection in the line or sudden change in the slope. Normally in ships you will find there are certain ships, of course, you will find there is a change in the slope that is given by a what is called a knuckle line, but this is not very common. It is called a knuckle, or sometimes you will find a chine. Now, at these positions of the ship, that is where the knuckle or chine is present. Now, knuckle I can explain here. You will find this is your profile of the ship. Suddenly, you have a change in the slope of this curve. This is a knuckle line. And in high-speed ships, of course, the hull form is different. You will find in high-speed ships, the hull form they have this knuckle is more pronounced, and it is called a chine. That chine is given with some other purpose in a high-speed vessels. Say this is a fast boat. Then this change in the slope, here it is called a chine. And normally you will find at the chine there is a spray strip attached to this chine. So the knuckle of the chine, at the juncture of the knuckle of the chine, you will find there is a abrupt change in the slope. Now here this chine you will find along with the spray strip which is on the chine, it serves the purpose of deflecting the water away from the hull. In high-speed ships, the more amount of water is directed away from the boat. That means the frictional resistance is reduced, the resistance or the drag due to the water is reduced, and you are able to propel yourself at a higher speed. So that is one of the reason of giving the chine. Another reason is that you can see that spray strip is there. Spray actually directs the flow of water away from the deck, so that you can have a degree of what is called dryness of the deck. Deck is not made wet. That is one of the reasons also of the knuckle coming into the hull. Sometimes you will find the ships they come and dock. So the knuckle they serve that purpose of directing the water away from the hull. And also you will find where you want to sometimes the complex curvature is avoided above the water line. Now knuckle, all these knuckle and chine you will find always above the load water line or dead water line, because if the knuckle goes below the water line, then there will be disturbance in the flow of water. But it is given for this purpose to deflect the spray and also to maintain to prevent what is called deck wetness. So deck wetness, I have told you that deck wetness is prevented by one or two. This is one of the reasons, one of the means by which you can deck wetness is prevented in the ship. Another is you give a certain height to the main deck. The main deck by the rules is given a at the forward perpendicular a certain height which is called the bow height. Now bow height is given in order to prevent your green seas from coming and crashing on the main deck. So because normally the crew will be they will be working on the main deck, and of course they will if the deck is always wet, they run the risk of falling overboard. So the deck has to be maintained dry. So that is done by these two. In high speed ships it is done by the chine, and in some boats the knuckle is given. You maintain a bow height, and another the deck is also given a shear. Shear also gives more height to the main deck. But this deck shear nowadays you can find that most of the big ships they rather avoid this shear, because then again they have to bend another plate to this curvature, and the construction problem is there. So nowadays the tendency is to make ships more production friendly. You have less curvature, and you just build ships in the minimum possible time. You don't waste too much of time on that. So again, just this is another point that one should remember. And I have talked about this shear and the camber. So this is called shear. So the amount by which the main deck is above a horizontal line passing through the lowest position on the main deck at midship. So that is called the shear. And forward perpendicular, this is called shear at FP, and after perpendicular, this is called shear at AP. Now in between the stations also you can measure the shear, and normally in the load line rules, that is the International Load Line Conference, they have formulated certain rules by which one can calculate the amount of the shear ordinates. So these are called the shear, the vertical distances from the horizontal line is called the shear ordinate. Anyway, so this has been discussed again. The shear and camber. Camber is also there. So that means the deck is having a curvature along the transverse section, that is called camber. Camber is the amount of height. This is called camber. Normally this camber is the breadth of the ship divided by 50, b by 50. By nowadays you have straight line camber, you can make this flat and then the rest slope. Again, ease of construction. Now, so far so good. So all these lines, so that means your knuckle line, your main deck, your buttock lines and water lines, the when one makes the drawing, one should remember lines to be smooth. Without abrupt change in slope. So this is very important. Abrupt change in the slope at a particular station or at some station is to be avoided at any cost. So you can see in this figure the lines that I have drawn, they are, that means they have a gradual slope, and the buttocks, as you come from the outermost buttock, the profile is nothing but the centerline buttock. Profile is nothing but the centerline buttock. So you can see the buttock lines from the side, the extreme side shell of the shape. You can draw the side buttock. As you come to the center line, the buttock will change its shape to that of the profile. It will slowly change its shape. Similarly, the water lines also, from the water lines that are coming, say, from just above the baseline to the deck, it will gradually change its shape from the shape that will occur at the baseline to that of the deck. Now, after one draws a line, suddenly in between these two curvatures of the, say, deck line or any other water line, suddenly one should not make another or draw a water line which is distinctly away like this. So that means this is wrong. So that means this water line if one has obtained from the table or from any other offset, this does not conform with either the water line that has been drawn below it, neither with the water line above it. So that means here you can see that there is a drastic change in the slope. Even if there is a drastic change in the slope, by knuckle or chine. So this should always be reflected in the body plan. The body plan sections are quite smooth, and if you find that the half breadth plan there is a sudden change in the slope between two water lines which are more or less having a smooth curvature, that means the outline of that water line as shown on the half breadth plan is wrong. So this is the major or first or prime, I mean the most important item that one should remember when one is making the lines plan, that the lines of the ship actually makes the shape of the ship, and it has to be in normal parlance what we call ship shape. All the lines is to have ship shape. That means there should not be any abrupt change in the curvature. And from the naval architectural point of view, one has to remember that the shape actually directs the flow of water to the stern. So here actually the flow of water will be following the buttocks like this, and then it will come to the stern. And if you look at the half breadth plan also, as the ship moves forward, that means the water is going to flow like this. So there should not be any undue hindrance to the flow of water, and this again is reflected in the sectional area curve. So the sectional area curve, suddenly you should not make a drastic change in the slope. All these slopes are given for that particular reason, and it should not have a shoulder. So this is called a shoulder in the sectional area curve. Now, whenever you are having a shoulder normally it will come, say, either in the forward region, say this is your midship, this is the forward perpendicular, and this is your aft perpendicular, and this is your parallel middle body. Shoulders normally come at this region, just the outer limits of the parallel middle body. So any sharp shoulder is to be avoided in the sectional area curve. If you have any sharp shoulder, then there will be a drastic change in shape at the station just forward or aft of the parallel middle body. So again that will be reflected in the your lines drawing. So this flow of water has to be unhindered, and if there is any uh, flow hindrance, it will be reflected as a turbulence. That means here the stern, the flow is going to separate like this. Instead of following the hull to the propeller, the flow is going to separate, and you will have what is called vortex shading and boundary layer. That means the ship will have a boundary layer flow separation at the stern. So here normally the propeller will be working and your water will be circulating in this fashion. It will be creating eddies. Instead of going into the propeller and giving thrust to the ship, it will start rotating. That means it will create more and more eddies and turbulence in this zone. So turbulence at this stern is to be avoided. Normally you find propeller suction water. So at this region actually it is a person who falls on board will be sucked into the propeller actually. So this is from the hydrodynamics point of view, all these points should be kept in mind. Now, technically after the lines have been drawn, that is the lines, your profile, half breadth plan and body plan, these are nothing but the orthogonal projections. In my first class I have talked that it follows a pattern called, in three-dimensional geometry we call it the first angle projection. So this is nothing but the elevation, half breadth plan is a plan, and body plan is nothing but the side elevation. So that you should remember. Now coming to the fairing. So fairing, the first part of fairing actually is the abrupt change in slope, lines to be smooth. This is the first condition of fairing. The second condition is projections. Projections of a point in any of the say in profile should be the same, should be same in other views also. Now, since this is a technical drawing that is being produced, now what I want to tell you is that suppose let us take station number 6. So this is the half body sections, and the water line, a 1 meter water line is intersecting at this particular point, say point P. So on the half breadth plan, you say this is water line 1, you go to station number 6, and here you can grade the breadth. So this breadth should be equal to the breadth on the body plan from the center line to point P1 will be the same here, P1 to the center line. Now, if that is not so, that means there is some gross error or mistake in the while drawing the water line. So again, you have to move the or increase the breadth at say station number 6 in order to make it same. Now, normally what happens when one moves a one point, you will find the other points are also moved, because the water lines are drawn by means of water lines drawn by battens. So that means battens are nothing but uh, very slender plastic strips which are placed on these points which have been obtained from the offset table, and then by means of a pencil one draws the line, and on the stations you place weights which guide the or makes the slope of the water line or buttock, whatever it is. Now, if you want to have a smooth curve, then suppose you have placed a weight in this region, another weight has been placed here. If you remove this weight, there should be no change in curvature or slope of the curve. Now, if there is a drastic change in the slope, if you want, when one removes this weight, the line goes like this. When one releases the force, then that means there is some error in the other points. So this buttock line is nothing but a spline. You should give a very smooth spline. So here the water lines drawn by battens, water should have water should be smooth, of course. So here now, even after one has done all this, you will find that your projections are not matching. Say the point P1 that has been projected on the body plan and also on the half breadth plan, they are not matching. You have to move this point, and consequently, if you again position the batten and move the batten like this, you will find that if you remove this point again, the batten will go away from the center line. So you have to change these nearby points. You have to make changes on the breadth on the nearby point. Similarly, also on the body plan, you will have to make changes, and finally, you will find that you cannot avoid changes in the profile view also. So that means just if you change the ordinate of a particular point in any plan view, it will be reflected in the other projections, and the nearby points also have to be corrected. So this process is called fairing till one obtains the projections of the measure of nearly all the points to be the same in the body plan, in the half breadth plan, and also in the buttocks. Now, these buttocks are the longitudinal sections. Here also you can find the projections. So this may be the distance of a point, say Q, from station number 2. If in the drawing one looks at the 2-meter buttock, say this is the point Q, so it is at a certain distance from station number 2. Now here again we can see from here station, of course my drawing is only a sketch. If you draw a lines properly, this distance should be the same here also in the half breadth plan. Now when one is not certain about the curvature, uh, in the drawing office you can draw intermediate stations. Yes, you can draw a half station or quarter station, and again draw the projections of this point from the profile and also on the half breadth plan. You check all these projections. So the next most important item after you have made a projections of a point in profile should be the same in other views. In profile or any other, say body plan or half breadth plan, they have to match on the corresponding views. If it doesn't match, if the projection of a point does not match or is not the same in the other views, then there is a drastic or a serious flaw in the lines drawing. So that is called fairing. And this process of fairing, that means constantly changing the point. I told you that if you change one particular point, not only you have to change that point on the profile as well as on the body plan. Say you change this point, then the buttock shape you will find will change. That means buttock point will change. Why? Because if you move this point outwards, your body plan will shift here. Then again the buttock, that which gives the vertical distance from the baseline. How are you going to check the projections from the buttock line? Buttocks actually give you the vertical distances from the baseline, so that has to be again made equal to the projections obtained from the body plan. So those again has to match. If you change the breadth will change here, your buttock position will also change, the buttock height from the baseline, and that will be made, that change has to be made in the profile view. If you don't make that change in the profile view, you will find the error. So again your buttock is going to change. So in one point, then again you have to change. I told you that if you draw the curve by means of battens, it has to be smooth. There should not be any high degree of change in the curvature. You have to move the next point, say in station number 6 or in station number 4. So again the outline of the buttock is going to change. So the whole hull form will change, especially in the surrounding point. Of course, the large distance from the point, the slope will be taken care of. That means you will not find, if you remove the weights from the battens, it will not change much. But the nearby points, of course, you will change because the battens have to be made smooth. So this process is called fairing of the lines, and before before the ship is built, that means the one has to make what is called faired offsets. So the naval architect has to supply to the shipyard, and of course his data will go via what is called the loftsman. So this faired offsets is very important. The faired offsets will give the correct lines. Correct lines can only be obtained if the fairing is done. So the process that I have just now described is called the process of fairing. And before that, the offsets are nothing but your half breadths. Say you draw a particular So this is the offset. You draw the particular water line and you take the hub breadths at the stations. Now these are the molded hub breadths, so these are called offsets. And these offsets are depicted in tabular form, that is called an offset table. And below I can write. So here you have an offset table. Offset table will show that horizontally your water lines and the vertical columns will be the stations. So here there is an offset table for a ship. So one has to supply the faired offset for production of the ship. Offset table is not here. Anyway, so I think I have not brought the data actually. Yeah, this is the offset table. So here horizontally you have the water lines. You make a table like this. So this mark water lines here, and these are the stations. So you can start from 0 station is what? Nothing but forward perpendicular. You can go to the 10th station. And water lines you start from say 0-meter water line, then 1 meter, 2 meter like this it goes on till you have the upper deck, forecastle deck. And actually in the offset table you will find upper deck breadth is given a little bit separate from these other water lines. Other water lines you can draw, but upper deck sometimes you find they may have a curvature longitudinally, etc. Upper deck breadths and also a height is given. In this offset table I think it is not depicted, but upper deck where it has a shear, the upper deck height has to be given. Upper deck and forecastle height at the particular stations, they will also be shown in the offset table. So offset table is very important, and only after lines are faired, lines faired, then offset table to be prepared. Now the suppose a naval architect or you have made the lines in say shipyard, drawing office. Drawing office, you are working in the drawing office, you have made the lines plan from your section area curve, right? And you have got a table of offsets, right? Now the drawing that you have made, the drawing of the lines that has been made in the drawing office is not to full scale. Let us say scale of say 1:20 or 1:100. For big ships it may be 1:100. So drawing is to a certain scale, and these projections even after fairing, these projections that you have made, if you expand them to the true shape, that is on the full scale, again you will find error. Say you have made, you are seeing only by the naked eye that this point is actually matching with the station, isn't it? Some red or some distance you have found, say 100 millimeter or 50 millimeter, but actually in the, if you expand it to your full scale, you will find it is quite out, say 110 millimeters and all that. So the offsets from the drawing office or preliminary offset, they are supplied to the mold loft. They are given to the mold loft. So mold loft, you will find there is a large script board, a wooden board lying on the floor, which has is quite large, and on that you find the profile has been drawn by means of a paint mark, and the other sections are also being made full size. So mold loft, the job of the mold loft, this is to make what is called the faired ship lines. Faired ship lines drawn to full scale. So this is his job. So the loftsman, the naval architect, he has to correspond with the loftsman, or he interact with the loftsman, and he will supply another set of offsets which may not match with the offsets that has been obtained in the design or drawing office. So the loftsman will say he has drawn the ship full scale, and again he has faired all the lines, and those are the final offsets that are to be taken when one makes or bends the frame. The frame is to be made in full scale. You cannot scale down a frame and give it to the hull shop. The hull shop dimensions of the frame, now actually the after the lines has been prepared, the and the offsets have been faired from the mold loft, then again you have to make a framing plan. That means the hull shop, he will not understand about, he is not much bothered about the sections at the stations. Hull shop is making a structural fabrication. So if you want the hull shop is to make a structural fabrication, he will want the outline of the frames. Frames are the structural members of the ship. So the hull shop supervisor will ask what is the dimensions of the frame. So these frame dimensions will be obtained after one makes the faired offsets in the mold loft. So the job of the mold loft is to make the full scale drawing of these frames. So he obviously makes the faired lines plan, and after that he makes all the framing plan. So framing plan has to be supplied to the hull shop, or frame sections, etc. All details. So that is why normally when one makes the lines plan, when one indicates the position of the frames, you will find in the lines, especially in the profile, the frame positions are also indicated. You just open any lines plan, you will find the small letters are the frames, and frame spacing normally in the British system it starts from the after perpendicular. The AP is your 0th frame, and you will find some arrows are given and some distances are marked. You can say this distance on the framing plan is marked 610 millimeters. So that means from 0th frame, say to say frame number 70, the frame spacing is 610 millimeters. So at these spacings, if you want to make a frame outline, you just drop a vertical and also on the profile as well as on the half breadth plan, and you might make the half breadths and create your frame outline. So that frame outline will give the molded line of the frame, that is the outer edge of the frame will come on the framing plan. So this is the outer edge of the frame, and the frame which is made of either it can be a T section or an angle section, it has to be bent according to the frame outline. So this is how the shape of the hull is obtained from the lines drawing. So here again the molded lines are very important for positioning this frame. The outer edge of the frame is the molded line. Similarly, the keel, the inner side of the keel plate is the molded keel line. The deck will be above the molded deck line. So these positions of the molded line are very important. Now, if you take a profile, sometimes you will find the floors. Normally, floors are not horizontal in ships, but they are vertical structural members. You will find a T section. Floor can be a T section, and how one has to position the floor, that means again on the molded line. That is the T section, one edge has to be placed on the molded line. So every shipyard normally follows its own practice as erecting the sections on the molded line. So this is normally this practice is followed. So this is your fairing of the lines, and of course the lines after they are faired and the frames are built, and then the shell plating is also made. That means you have to develop the shell plate by either in a shell expansion drawing, or if one is the ship surface is what is called made of simple curvature, then you can just develop them on by what is called by normal geometrical means. So this is called surface or developing hull surface. So the frames are bent to the curvature, but the hull surface will normally consist of plates or shell plating. Now this shell plating has to be developed. That means you have to give the exact information to the hull shop that the hull shop is normally will have, say, a rectangular plate which comes from the steel mill, that will be a rectangular in shape. That will obviously not be cut to the shape that will go into the ship, isn't it? So all the dimensions and nesting is done in the plate itself after the surface has been developed. You develop the surface, that means in the shell expansion you can lay the guts on the various stations and you make a surface that is developed on a two-dimensional drawing. This is called shell expansion plan. So this will give you the nature of the plate, and then these plates are cut, and if you have a mathematical surface, you can just break the hull into smaller patches and develop those regions, right? So that will be more accurate, and you can nest the plates here and then cut it. So that is the main job of the naval architectural. Now sometimes the methodical series lines is also obtained. Methodical series. Yes. So